Okay, welcome back to our 7-1 Chemical Names and Formulas Lecture 2. Today we are going to continue on with writing ionic formulas from ions or from names. And it's going to be very similar to what you did last class and with the last lecture. But instead of just using our monatomic ions, we're going to introduce polyatomic ions and use those as well. The crisscross method is still what we'll be using to get our charges to be equal and opposite, and it's very similar. So once you kind of get used to this, using the polyatomic ions, it's not much different than using your monatomic ions. So let's jump down to your notes with the polyatomic ions. These are ions formed from many atoms, and most of them are oxyanions, meaning that they contain oxygen. So you'll see that when we look at the list of common polyatomic ions. Another thing you're going to see is that a lot of times those ions are going to end in ATE or ITE. And how to differentiate between those two is that the ATE ending, what you can't tell from that is how many oxygens it actually has. Some have 3, some have 4 with the 8 ending, but that's the most common form. But what you always know is that the ITE ending is always going to be 1 less oxygen than the ATE ending. So let's look at, and we'll look at a couple other ones here as well, a couple of examples. NO3 minus 1, that's a polyatomic ion. It's an oxyanion. It contains oxygen. Its name is nitrate. Okay, you can see there it has the ATE ending. Now NO2 minus, which has 1 less oxygen than nitrate, is nitrite. So it has the ITE ending. So you can always tell, if you know the 8 ending, you can always get to the 8 ending. But one other thing is you don't have to remember these. You'll have the list and the sheet for your homework, for your test, whatever you're going to be doing. So in your 7-1 folder is your common polyatomic ion sheet, and here they are. Okay, lots of 8s and 9s in there. Here's one example here: chlorate and chlorite. The AT ending being O3, so ClO3 minus 1. And the ITE ending being ClO2 minus 1, so it's 1 oxygen less. There's the nitrate and nitrite we talked about. With the minus 2s, sulfate and sulfite. So sulfate is SO4 minus 2, and sulfite is SO3 minus 2. And then lastly, down here in our minus 3s, you have your phosphate and your phosphite. Phosphate, PO4 minus 3, phosphite, PO3 minus 3. So like I said, you don't have to remember these. You're just going to have to look them up. If you have a formula that has bromate in it, you're going to have to go to your polyatomic ion sheet and find that bromate is BrO3 minus 1. Another thing here, we have one positive polyatomic, and it's called ammonium, so it would be written first. It's NH4 plus 1. So you'll be seeing that as well. And then also with these, and the monatomic ions are always there. These are the same ones you used last class. In the last lecture, is you'll be using these. So this sheet will be being used as well. Okay, so let's get back to our notes. All right, and we're going to go down to, here's our crisscross method again. These are the 3 examples that we did last class. Okay, then we're going to work on these 3 down here, then do a couple of other examples. So it's the same method. It's just writing those symbols side by side with the charges, crossing over those charges to make them equal. If they're not already equal, you just write the 2 ions side by side. Here's an important thing though, right here. Use parentheses if more than one polyatomic ion is being used. So to show, since a polyatomic ion is a grouping of atoms, you have to put those in parentheses to show that you have a grouping of the whole thing. Okay? And again, it's just the same method, this crisscross method. So let's look at Cr plus 3, chromium 3, and OH minus. This polyatomic ion is called hydroxide. So let me go to my pen down here. We can use the red, that's fine. So remember what you do. The plus 3 is here, so we crisscross our charges. We're going to have 3 here, and then we're going to have 1 right there. So we have to write this with 1 Cr plus 3, or 1 Cr technically, and 3 OHs. So we have to show 3 OHs. So we don't multiply that out. we're just going to put OH in parentheses with the 3 outside. So the 1CR is just going to be CR, and again, sorry about I'm using just my touchpad here, and it's a little bit difficult. So CR, and then to show 3 OHs, parenthesis, OH, close parenthesis, subscript 3. Okay, so to sort of say this in words, it is chromium 3 hydroxide, Cr, the quantity OH taken 3 times. Okay, and that's how you would write it. If you just wrote CrOH with a 3, that would be incorrect. What that would really show is that you had 1 Cr, 1 O, and 3 H's, not that you had 3 OHs. This hydroxide comes as a group, so you have to write that accordingly. Okay, so let me erase this. And let's try the next one. So we have NH4 plus. This is that one positive polyatomic I talked about. It's called ammonium. And here's S minus 2. That's sulfide. That's a monatomic. Okay, so we need 1 of those. And we need 2 of these. Okay, so we have to show 2 of this NH4 and 1 of the S. So to show 2 of the NH4, again, we have to use parentheses. So open parentheses, NH4, okay, close your parentheses, 2, so that's showing 2 of that whole thing, and then just S. We have 1 S. Okay, so ammonium sulfide is the quantity NH4 taken twice, S is how you'd write that final formula. Okay, now let's take a look at the next one. Let me erase this real quick. Okay, now here's one, and I kind of mentioned this a little bit last class, but if you have already equal and opposite charges, so we have a +2 and we have a -2, you don't have to do the crisscross method. You're going to have one to make these equal and opposite. They already are equal and opposite. Okay, so you have 1 of each, and you just have to write it accordingly. So really, just put these together and take out the charges. So even if you brought the 2 down here and brought the 2 down here, that's not the simplest ratio of copper 2 to sulfate, 2 to 2. The simplest ratio in how we write ionic compounds is to show that it would be 1 to 1. Okay, so you would just write this CuSO4. Okay, CuSO4. That's it. Note, SO4 is not in parentheses because there's only 1 of them. So you don't have to parenthesize that or put it into parentheses. Okay? All right. Now, more of what you'll be doing, is going from these names. This is what you'll be doing on your homework, going from these names to the formula itself. Okay, so let me erase that top one up there and go back here. So these 2 we already did. We did copper 2 fluoride. We did barium phosphide. Now, sodium sulfate actually contains 2 polyatomic ions. So, or excuse me, 1 polyatomic ion. That's why we didn't do this first example last time. Okay, so sodium, the sodium ion, that would come from this monatomic ion sheet. There it is right there, Na+. Sometimes the pain in these are just finding them on these sheets. And then the sulfate ion, we did just look at that one. Here it is right here, SO4 -2. So let's go back to our notes. And sodium will be Na+. One. You really don't need the 1. You can include it if you want, but just plus means that it's actually a 1. And then sulfate will be SO4 -2. Okay, so there's our 2 ions. We have a +1, we have a -2. So if we crisscross our charge, we're going to have 1 of those, 2 of those. We have to show 2 of these and 1 of those. So to show 2 NAs, that's a bad A, sorry, Na2, no parentheses because it's a monatomic. You don't have to put those in parentheses. And then 1 SO4, SO4. A little better right there. There we go. So the final formula for sodium sulfate, your final answer, Na2SO4. Okay. Now we're going to do these 3 more, and then we'll be finished for today. And then this is what your homework's basically going to be on. Okay, I have to go back to this, sorry, to bring that right here. Okay, and here we go. So gold 1 chlorate. So gold 1, that's a monatomic. And I can't go down, I got to change my thing here. Okay, there we go. Gold 1, Au plus 1. Okay, so that's Au plus 1, remember that. And then chlorate, here it is right here, ClO3 minus 1. Okay, so let me write these out. So gold 1, Au plus 1. Okay, that's a bad plus. ClO3 minus 1. Okay, so now these are already equal and opposite. Okay, you don't have to crisscross. And even if you did, you'd have 1 here and 1 here. But if they're already equal and opposite, you don't have to crisscross. So my final formula, AuClO3 So AuClO3. No parentheses needed. You only have 1 of each. You wouldn't have a parenthesis on Au anyways because it's monatomic. So AuClO3. Okay. Let me erase that one. All right. So you kind of know where to look. You'll go to these monatomic and polyatomic ion sheet. If you have a printer at home, you want to print those out. Or if you kind of want to, I just have 3 windows open up here so I can just quickly pull them up. That's kind of up to you. So the next one, strontium nitrate, to save us a little bit of time. So you know where to look those up. I'll just let you know what those are. Strontium is Sr plus 2. Okay, so we have Sr plus 2. And nitrate, you kind of looked at this one before, and I'm getting a little wild there. NO3 minus 1. Okay, so we have Sr plus 2, NO3 minus 1. We crisscross our charges. We're going to need 2 of the NO3. We're going to need just 1 of the Sr. So to show 2 of the NO3, we are going to have to put that in parentheses. So let me write your final answer. Sr, and then we have to show 2 NO3. So parenthesis, open parenthesis, NO3, close parenthesis, taken twice. Okay, so our final formula, final answer for strontium nitrate, Sr, the quantity NO3 taken twice. Okay, and our last one here is nickel 2 chromate. Okay, or excuse me, nickel 3 chromate. Nickel 3 is Ni plus 3. Remember, when you have those ones that have the Roman numerals, that stands for the charge. So that helps you figure out what the charge is, makes it pretty easy. So we have Ni plus 3. Now chromate, that's a polyatomic ion. It's CrO4 minus 2. Okay, CrO4 minus 2. So since we have plus 3 minus 2, we have to make those equal and opposite. So this 3 comes down here. We're going to have 3 CrO4s. Let me just change color here. Do that just for this one because it's a 3 and a 2. So we're going to have 3 of these, and we're going to have 2 of those. 2 nickels. 2 nickel 3s, 3 chromates. So to write your final answer, slide back over here. I'm going to write it over here. So we have Ni, nickel. We have 2 of them. And we have to show 3 chromates. So again, parentheses, CrO4 taken 3 times. So that's your final answer for nickel 3 chromate. Ni2, the quantity CrO4 taken 3 times. Okay, so on your homework for today, you're going to be asked to write, you'll be given a name, you'll be asked to write both of your ions, and then you'll do the crisscross method and write your final formula. Then you can check that with the provided answer key, then make sure you answer your assessment question to show that you did your assignment.